Hello class, my name is Jacob.
And I'm Emily.
And today we're going to teach you everything you need to know about cubic functions. Let's start out by looking at what it looks like algebraically. It's written as so: f of x equals ax cubed plus bx squared plus cx plus d. The cubic function in any form will be written as so, where a, b, c, and d are constants and a is not equal to 0. Now before we show you how to solve a cubic function, let's look at what this function would look like graphically. I'm going to bring it over to Emily, who will elaborate more on this.
Thank you, Jacob. So here's an example of what a cubic function would look like on a graph. I used the example equation 2x to the third plus 2x squared plus 2x plus 6. As you can see, it goes up, crosses through the y-intercept, then continues going up. However, the shape of the cubic function can vary based on the coefficients. So as you can see, our coefficient a in the first equation is smaller, it's a 2. But if we were to change the coefficient a to a larger number, like 25, we see that the function becomes thinner on the graph. So when it's smaller, it's going to be wider, but when it's bigger, you'll see that it's going to be thinner. Also, if you change the coefficient a to a negative number, you're going to see it switch sides, so it's going to reflect. So instead of going, like we see here, starting from the bottom and going up, it's going to start from the top and go down. The last thing I'd like to point out is the d constant of your equation. The d constant is going to control where it's going to cross in the y-intercept. So this one right here, we can see our d constant is a positive 18, and we can also see it cross on the at 18 on the y-intercept, as opposed to if the d constant is a 6, we see it crosses at the 6. Now as for the b and c variables, those are going to help you find out what the x-intercept is by solving the equation. So I'm going to show you guys how to solve the equation. Alright, so you're going to want to get an equation. I use the example x to the third minus 4x squared minus 9x plus 36, and you're going to put it in standard form, so just equal it to 0. And then your first step is going to be to factor. So after factoring, we get a x squared multiplied by x minus 4 minus 9 multiplied by x minus 4, and then equal to 0. And then with that, you can see that we're left with a common factor of x minus 4. So you're going to take the two numbers on the outside, the x squared minus 9, put them in parentheses, and then multiply that by the common factor of x minus 4. And then we can see again that we can factor the x squared minus 9. So after we do that, we're left with x plus 3 in parentheses, x minus 3 in parentheses, and then an x minus 4 in parentheses. So our last step is going to be to set each of them equal to 0 and solve for the solutions. And so after doing that, we get x minus 3, x equals 3, and x equals 4. So now I'm going to bring it back over to Jacob, and he's going to explain how we can see cubic functions in the business world.
Thanks, Emily, for explaining what the cubic function would look like graphically, and also how to solve one of these functions. Now, let's apply it to the real world. Being that this is business calc, it is important to figure out how our functions can be used in the business setting. When it comes to cubic functions, the best examples we can think of include business products and practices that emphasize the importance of volume. For example, the world's largest internet retailer, Amazon, uses the cubic function every day. The boxes that they send out their products in need to be the right volume, or else their products could potentially be damaged before they reach the customer. Coming from the parent function, x cubed, we can use the volume formula, volume equals s cubed, where s is the length of one side. With this equation, we can calculate the volume of any cube or box. Other businesses that may need to use the cubic function include pool companies, as they need to know the volume of their pools, and kitchen supply manufacturers, who need to know the volume of their pots and pans. That concludes our video. We not only hope you learn more about cubic functions today, but we also hope you look back at this video if you need more clarification on the subject. Thanks for watching.